Today I will be very briefly, but I will make sure as brief as I will, you also understand. Ish. Last we were talking about applied load. When you apply load there, what would be the total extension? If this 1 and area 2 or bar 1 and 2, what would be the total extension? Sorry? 1 plus 2.
It's 1 plus
Extension 1 plus extension 2. So what will be straight total? Sorry? Strain 1 plus strain 2. Same applies as strain energy. That would be for 1 plus for 2. So strain energy is equals to 1 over 2 Fx. Force times change in length. So this one will be the change, it will be the total change in length. So when we substitute here, we end up having 1 over 2 force times L over AE, which this one it gives us F squared times L over 2AE. So that one end up being our equation to calculate strain energy. So meaning the total strain energy for this one, for this one, this two, it will be total strain energy is equals to strain energy 1 plus strain energy 2, which it will give us 1 over 2 or F squared. Sorry? Times L over 2A E plus F2 squared times L 2 all over 2A 2E2. With that equation, what can we say about that equation? The one that I just written.
Forces are the same.
Sorry? Come again? The forces are the same. This force and this force is the same, né? Because it's the force which is being applied, meaning these two, they have the same force. Meaning you can still say F into L over 2AE 111 plus L2 over 2AE 22. It means there must be a square because the forces are equal. So this F It will also depend how do you apply the F. Let's take you're having a rod here, and this the same rod, area 1 and area 2. This one, it's a wall, the rod is hanging there. So after that, here, we have another bar. But this bar, you ignore it. The purpose of this bar is to hold this one so that it does not fall. You understand? Agree, when you apply force, it's either you come and put here. You understand that one? And you put this weight here. We have this weight here. Putting this weight here, it means it's the one which it will be applying force on the rod 1 and rod 2. You understand that part? This weight is the one exerting the same force, this force. This force is either you come and put it down here, or you just put another weight here. This weight, it will push this one downwards. So, but before you start, you start pulling this one downward with by the use of this weight. You can have you can have a block there, also block here. So this is ground. So meaning, as I put these 2 blocks, therefore, this weight, you use that applied force. But if you are having a weight, so with the 2 blocks, when you remove this block gradually, it means this F is equals to W, the weight of this one. But if you suddenly remove it, it's twice. Your force twice the weight. So you should remember that before you calculate. You check if there was a weight there. Sometimes they will just give you a force. If they just give you a force, no problem, you just substitute there. But if you are given a weight, do as wise. So, lastly, we have something which they call it a shock load. A shock load. This bar, there can also be 3, 4, 5, or 1. So if there are 5, it means here you will add up until 5. If it's 1, you will only use 1. So, but I will be using 2. So this one, this is just there to block a weight. You put this one here to block the weight. So now, here is my weight. There is the weight. Is this weight part of is the weight part of these 2 rods? What is the function of the weight there? What is the function of the weight? What was the function of this weight? To exert force, ne? To apply a force on this 2 rods, ne? Yes, that's the function of the weight, that weight. So the difference is, this one here, it was already on this surface. What we had to do, it was to remove these 2 apart in different manner. The first one suddenly, the second one gradually. So in this one, we take the weight a little bit up at a certain height between where it's gonna start exerting the weight and where will be our dropping point. So that is the height where we will be dropping it from. So now we are talking about a shock load. Do you still remember the saying whereby they say energy cannot be destroyed, ne? But what? Converted from one point to another, ne? Yes. So we used to say potential energy at the top is equal to kinetic energy at the bottom. Those stories. Yes. So here, since we will be dropping this one, meaning potential energy here, it will be the same as strain energy. Potential energy will be the same as strain energy. Potential energy is equal to strain energy, total strain energy. Total potential energy is equal to total strain energy. So, how do you calculate potential energy? MGH, ne? Potential energy is equal to MGH. And strain energy? Sorry? It's F square L AE, ne? But this one is provided only if it's what? Only if it's one rod. Remember, if we have two rods like this one, your total strain energy, it will be strain energy 1 plus strain energy 2. You understand that one? Eh? Yeah. So in this case, for this one, is this formula correct? No. What must I do? I add, ne? Yes, I add. This one is 1, 1, 1, 1. I add for 2. F2 square times L2 all over 2A2 times E2. This is our strain energy. So, but then, let us look at our height. Let us look at our height. Is this height the total height which this one will follow? Is that will be the total height? What will be the total height? What will be the total height? Tata? Okay, let us look on this one. The total height. Remember, this thing, when it falls down, it will exert a certain force here, ne? Meaning there will be a tensile force here. And as there will be a tensile force, therefore this one, it will expand to somewhere there, right? As this one is expanding, also this one is expanded somehow. You understand that one? Eh? Yes. Meaning both of them, they have expanded. Meaning at the end, you may find that this one is somewhere there. So at the end, the distance being traveled, your h, is the original h plus your change in length. That's the total height. Meaning on this one, you cannot just use only h. You need to use the total height which it was traveled by the weight, which it will be mg into h plus x is equals to this one. Let me write it this side, which will be mg into h plus x. X is the total x, ne? Yes. Is equals to f square 1L1 over 2AE11 plus f square 2L2 over 2A2E2. This I said is a total change in length. For this to change in length, what will be the total? How to calculate the total change in length for these two? Calculate change in length. How do I calculate change in length for these two? The total change in length? Yes, it will be mg into h plus, how do I calculate this one? Is f times l over ae for 1, eh? Plus f l times l is 2, eh? Is equals to f squared times L 1 over 2A1 E1 plus f squared 2 over 2A2 times E2. Is there anyone who did not understand this formula? So here, it will depend on how many rods do you have. If you have 3 rods, it means this one will add up until 3. Also this side will add up until 3. So the question is this force the same as this force, and is it the same as that one, also the same as that one? Or these forces are different? Sorry? They are the same, eh? Yes, because that is the force which is being applied there. And this force, it exerted on this one or on that one. The force is the same. That force is the same. But if you check, you may end up required to solve quadratic equation. Because here you are having f squared and the f and the constant. Maybe we should do one example so that you understand what I'm talking about. So this one, what is this? And this one? Gravity. What is the unit? Unit for gravity? Yes. Meters per second square. Ne? And the unit for this one? Is what? Kilogram. So if you are given Newton, they say your weight is in Newton. Or they say your mass is in Newton, or your weight is in Newton. What is it that you are given between the two? You are given both of them, ne? Yes. I just wanted you to the only portion which you did not understand. Oh, I forgot to tell you something. You see, when you are having this thing, this two rod, and this one it falls from here, from there to there. Then there was another student who once asked me, why can't we take the total length of the tube and we make it the total height? You cannot do such thing. Yes. Like they say calculate the height, the what do you call this one? The height. Yes. So you cannot do so because this one, it's not always that they put it on top here. They can come and they can decide and put it somewhere there. So what you will need to calculate is that distance from here to here. If they want you to calculate the height. It's not always the fact that it must be on top there. Should it happen that you do an exercise, it happens that this height, before the substitute, this height is the same as the length of this one and this one. It means this one they put it on top. But that is not always the case. Do not assume. Yes. Yeah. What I have learned from doctors, what I have learned from the doctors, if you do not know the spelling, just write something which is in others they cannot be able to read. Oh, it's true. That's my handwriting. I'm sorry. What's the diameter of this one? It's 4. 12. And the diameter of this one? How long from there to there? Sorry? 150. 150, they say the weight fall. Sorry? 940. What is it? 940. They say is vertically having the length of 900. Ne? It has a diameter of 12. For the length of 600 and the remaining of 600. This one is how much? 600. And this one? 300, somewhere there to there, which is 150. This one? Yeah. So we have this one. Stress equals to force over area. So you will use the force, the area, and the area to find the maximum one which they are looking for. We do not, we can calculate the area, we can also calculate the force. So how do we calculate the force? Shock load. Shock load. Is correct, ne? Okay. Let me write here. Under shock load, we have mg is equals to h plus f l over a1. Is it not the same? It's the same. Yes. Okay. Plus F2 L2 over, even F is the same, right? Yes. Even if I did not indicate that 1 or 2. A2 E plus F square L1 over 2 A1E plus F square L2 over 2A2E. Did I write it correct? Which one is missing? This is equal. Yeah. When I go wrong, it means you are also wrong. Yeah. I cannot be wrong alone there. I know we did talk about this. So I apply. If I write something wrong, it means you are also wrong. It's not me who's wrong. All of us were wrong. So okay. We said stress is equal to force over area, meaning we should find the areas. So which area here? Is it the total area? Mathematically, can we say total area? Total area for these two is equal to area 1 plus area 2. Let's see a share. Yeah? Yeah, it's right. Mathematical, we cannot do so. Mathematical. Yeah? What is that? That one I do not know. Maybe on that one is possible. So okay, let us find area 1. Area 1, we'll take this as area 1 and this as area 2. So area 1, it will be pi d squared over 4, because the side there, yes. Which it will be pi times 0,012 square over 4, and what do you get? Sorry? 0,113 meter square. Is it in? Is meter square like that?
I said, so you're wrong. I was wrong. 0,0001.
It's right. Times 10 to the power negative 3. Negative 3. Negative 4 is when the comma is here. Use your calculator very well.
Says 1,131.
Punch engineering mode. Did you punch engineering mode?
Yeah.
You could ngaki?
I
Press shift first before engineering mode.
Okay.
Do you know engineering mode?
Oh, yes.
Oh yes, yes, yes.
Yeah. So the second one? No, it's like this one. When you press engineering mode, if your answer is -4 times 10 to the power -4, it will go to the next one, which is -6. Then from -6 it will go to -9. So if you start with a shift, from -4 it will go to -3. Then yeah, the other one goes this direction, the other one goes to this direction. Yeah. Agree times 10 to the power negative 3 is millimeters.
Yes.
Then times 10 to the power negative 10 is micro. So your engineering mode, it makes sure that it goes with millimeters, micrometers, something like that. You understand? So that is why it won't give you -4. Because -4 is not, yeah. You understand? So what's the answer then? 0, 1? 1, 3. The second one. Punch engineering mode.
0,064.
Punch engineering mode again.
0,064.
Engineering mode.
64.
I don't want many zeros.
Yeah,
63. 63, comma
617.
617 times
10 to the power minus 6.
-6. I did not want. Okay, maybe I did not explain it very well. What I need is your answer to be in engineering mode. We want to eliminate lot of zeros by putting it in engineering mode. If you find that after you have pressed, then it gives you, let's take you are having this one, 0,000002. After you have pressed, it will come here. Then meaning you need to press again so that we can eliminate as many zeros as we can.
But then the first one has 1 0.
The first one, this one is bad. This one is 0,0. Yeah, this one is bad. If this one, you can also write it as 1. It's the same answer, guys. You know what's the difference? If you are having this one, 0,0000945. So if you decide like you want to, you can still write it 0,00945 times 10 to the power negative 3. Ne? But remember 3 decimal after comma, it will end up here, meaning it will be 0,01. And now it starts to change your answer, decimal. So I want to avoid those things. That is why it's better. This one, to write this in like not having a comma is better than having starting with a comma, more special for this chapter. I'm not sure if you understand. At the end, you must check your answer. If you use a lot of zeros, you'll find that your answer is far from the correct answer. But if you put your calculator in engineering mode, you become closer to the correct answer. Or you get the correct answer. So now we have our areas. Is there anything we need to calculate separately? Nothing, eh? We can substitute now.
What about the length?
Eh? See it?
Oh,
Yeah, we do have the length. So this one, it will be 90. And look here, our weight is in Newton, eh? Meaning the force which we are going to get, it will be in Newton. If you substitute this weight in kilonewton, the weight which you are going to get here, the force which you are going to get, it will be in kilonewton. Yes. The length, it must be in meters all the time. Area, meter square, not millimeter square, meter square. So this one, it will be 0.15 plus F times the L is what? 600, 0.6 all over this, the area 1, 0.113 exponent negative 3 times 210 exponent 9 plus F, the second one is F times 0.3 all over 63,617 exponent negative 6 exponent 10
No.
plus, no, times 210 exponent 9. Then I close the brackets. Then come that equal sign. Because I do not have a space, I'll come down there. But know that this equation and this equation is 1. So it will be F squared times L1 is 0.6 over 2. It's like copying the same thing but multiplying by a half, ne? Yes. If you get that. Times 0.113 exponent negative 3 times. But let me erase this thing and write it correct. No, shorter way. We have mg into h plus. We said F is the same. I can take it out. Then we said E is the same. I can also take it out. Then I said L1 over A1 plus L2 over A2. I close the brackets. Same applies. F squared is common over 2A, 2E. Then I'm left with what? 1 plus L2 over A1 over A2. So, this one closes there. This one here is 90 into 0.15 plus, we are looking for F over 210 exponent 9 into 0.6 over 0.113 exponent negative 3 plus 0.3 all over 63.617 exponent negative 6. Then I close the bracket. Now I'm going to substitute this one, which is this one here, is equals to f squared over 2 times 210 exponent 9 into 0.6 over 0.113 exponent negative 3 plus 0.3 over 63.617 exponent negative 6. Both mass is 90 into 0.15 plus F. When you take this one, you add with this one. You multiply with this one, what you get? Your calculator can do that one fast and quick. I trust your calculators. Yeah. Because here we're dealing with a very small number. What did you do? You took this one, you added with this one. Then after adding the two, what did you do? You take this, you add with this one, then you multiply by 210.
Yes.
1,210. 1 divided by 210. 1,210, I do not understand. Now you need to take this one, you add with this one. Then after adding with this one, you divide by this. Yeah. When you multiply, you need to multiply it by 1 over 210. If you multiply. What do you get? 4,774. Exponent negative?
9.
Sorry?
47,605 times 10 to the power 9.
I see you. 47? 47,7? 1, 2. 2, 1.
7 to 1. 7 cents and 189.
But when I'm telling like, oh, sis, oh, you told it.
No.
Ingakhosi.
7.
It's 47.
We divide. It times I. Hey, 1 over 210.
Which is divided by. It's
Okay. Yeah, I think you're right.
This one is 47,74.
Yeah. Yeah.
74, ne?
Yeah.
Okay,
Oh, what I'm saying, we are dealing with a very small number.
Yeah.
If you can check -9, it means you are having 0,000000007. So, how many units are you going to run? Are you going to run to 3? If you run to 3 left with 0, meaning everything has become 0. That is why I'm saying you need to press to put it in your engineering mode. Sorry? Yeah, you are trying to remove. Here, look here, sis. Here, even if you can say it's this 1,8 here, then you round. That one is bad. You're gonna still get the correct answer. You understand? Yes. It doesn't matter whether you put it here or here, as long as you have eliminated this all. Yes. And another thing, from here, I know I've substituted. As long as anyhow you calculate, as long as you apply mathematical principles, you will get the correct answer. Even if you can first check this, you multiply with that one, you take that one, you multiply. It's up to you how do you solve it. So this one we are done. So it's equals to. When you take this, you multiply with this one, then you. Either you take this one, you add with this one.
Yes.
Then you multiply by 1 over this one, which is the same as taking this one and divide by 2. Sorry?
23,820.
F is equals to 23, 870 exponent negative 9. Do you understand when I say it's the same as taking this one and divide by 2?
Yes.
I think the difference is this 2.
Yes.
On this formula, we do not have the 2, here we do. But if you do not understand, just calculate. Yo, yeah, I forgot the square, ne? Yes. So from here, it's up to you. It's either you take 90, divide both sides, or you take this 90, multiply here, and you multiply it there again. Mathematics allow us to do so. So how do we do?
Let us use the quadratic.
Let us multiply.
We multiply. We take this one and multiply with this one. We divide, ne? Okay, it means when we divide, we'll be having 0,15 plus 47,74 exponent negative 9. F is equals to, this one when you divide by 90, what do you get? 2,652 negative 10.
Yeah.
F square, ne?
Yes.
Yes. If you check negative 10, this one, yeah, when you pass engineering mode, it will take you to, it's either negative 9 or it take you to 12. Yes. But even if you can write it like this one, it's still correct. You have eliminated those zeros. So okay, now it's a quadratic equation. Is 2,52 exponent negative 10 f squared minus 47,74 exponent negative 9f is equals to 0,15. No, not equals to. It's minus. That is equals to 0. Did I write it correct?
Yes.
Yes. So, again, it's also up to you to solve this mathematical. Some other people, they will prefer to have A as 1. If you prefer to have A as 1, it means this one, you will divide by this one everywhere. Do you understand?
Yeah.
Okay, solve for F. Here we have F squared, here we have F, here we have constant, then we have 0. Solve for F. What do you get for your F? Solve for F. Quadratic equation.
Yeah.
Twenty-three
691
9 kilonewton, eh? It's correct, ne?
692.
Oh, 692
Yes.
kilonewton.
Yes.
The other answer, what do you get?
That one should be negative.
This one should be negative.
Yes.
The other one,
It's
23,872
23,872.
kilonewton. In this book, they get 23,7, negative 23,712 or 23,89. Still, it's the same answers. Force. So the question is, which force are you going to use? Which force are you going to use? Sorry? So remember our aim to calculate this one was to calculate maximum stress, ne? So meaning you take this positive answer, you substitute here for you to get the stress. Then you also take, you will substitute the force here. Then you take this area, you substitute there. You also take this area, you substitute there. Then after that you will tell which one is the maximum stress.